Hi, boys and girls, and welcome to Chapter 8, which is called Dividing Fractions. In this lesson, we will learn strategies for dividing fractions, and we will also set up equations that help us divide fractions. Our goal is to understand how to divide using whole numbers and fractions. And as you can see, we really want to be able to solve real-world problems using whole numbers and fractions to divide. Many of you have been avoiding a level 4, which means writing a real-world problem using whole numbers and fractions to divide. I encourage you to reach for a 4 because if you can write a real-world problem to divide, that means you truly understand the concept. What mathematical practices will we be using in this lesson? We will definitely be making sense of problems and using them to solve, or using what we've made sense of to solve and persevere. We always have to attend to precision. We will make use of the structure of an equation and we will look for repeated reasoning. And hopefully we'll get so good at it that we can critique the reasoning of others. We also should be able to reason abstractly and quantitatively. We should be thinking about what makes sense. And finally, we will be using 2 different models to help us solve problems. Before we begin, let's make sure we understand the relationship between multiplication and division. Now, you might remember inverse operation. In 2nd grade, we talked about addition and subtraction, and then in 3rd grade, we started introducing multiplication and division. And you've been doing that for what, maybe 3 years now? Well, this is an example of an inverse operation, or the relationship between multiplication and division. That's called a fact family, and you might remember that. So we will call these 4 facts a family. Here is what you might have remembered from the past. 3 times 4 is 12, 4 times 3 is 12, 12 divided by 3 is 4, and 12 divided by 4 is 3. That is true for fractions as well. If 6 times 1/3 is 2, that means that 2 divided by 1/3 is 6. Feel free to pause the video and look at this relationship a little bit longer. Keep in mind, boys and girls, the math that you're doing looks a lot like the math that you've done before. The only thing that we're changing is the values that we are multiplying or dividing. So boys and girls, make sure you pause so that you can take a look at the relationship between these numbers. Let's take a look at our first problem. Shauna has 5 different candy bars. She wants to share each of the 5 flavors with her 2 friends. She cuts the candy bars into thirds. Notice that she's not sharing them among her 2 friends. She's sharing them with her 2 friends. So that means that there will be 3 people who are sharing these 5 different candy bars, and she wants each one of them to try one of the different flavors. So she's going to cut them into thirds. So the question is, how many 1/3 size candy bar pieces does she have? Let's use the information that we have to write an equation. We know that Shauna has 5 different candy bars. She wants to share each of the 5 candy bars with her 2 friends, which means she must divide them into thirds. So we're taking 5 candy bars and we're dividing them into pieces, and those pieces are called 1/3. How many 1/3 pieces will we have? Our unknown, which is what we're trying to find, which is how many pieces, 1/3 size pieces she will have, we're going to indicate that using the letter A. Now let's go back and look at what we learned before. If 5 divided by 1/3 equals A, then I know that A times 1/3 must equal 5. For those of you who really understood our last chapter very well, you might be able to figure out what A should be. If using the multiplication is complicated, we can use a model. Let's start by using an area model. So we have 5 candy bars. Let's assume that these are all the exact same size. And we need to divide each candy bar into thirds. How many thirds will we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 divided into thirds means I will have 15 thirds. Some of you might be thinking, oh my goodness, Miss Addison just took a whole number, divided it by a fraction, and got another whole number that's larger than both parts. I know, but let's look at the inverse operation to make sure we understand why this is true. Let's multiply 15 and 1/3. 15 times 1/3. Now it might make sense to you. If I take 15 thirds, how many wholes will I have? Now you've got it. I would have 5 wholes. So when we see this whole number 15, this 15 represents the total number of thirds that I would have. Does that make sense? We're counting the thirds that I have. That's why I have a whole number. Let's look at another model, a linear model. Here we have an area model. Let's now look at a linear model. I've already divided each section into thirds. So the question is, if I have 5 whole candy bars and I divide it into thirds as I've done for each candy bar, how many total thirds do I have? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hopefully that makes sense to you. If not, just rewind it back and watch again. Let's move on to the we do. Here we have Shauna again. Shauna wants her 4 friends to run equal parts of a half marathon. I'm going to write those words in the form of a number because there's my fraction. What portion of a full marathon will each friend run? So she wants her 4 friends to run equal parts of a half marathon. Uh-oh, that is not 4 divided by 1/2. That's actually half of a marathon divided by 4 friends. Each friend is going to run an equal part, but it's actually only half of a marathon. So we're actually looking at 1/2 divided by 4. Our unknown, let's switch the letter and just put y this time. So a half marathon divided by 4 friends equals y. What's the inverse? 4 times y equals 1/2. You might be able to figure out how do I divide or what do I multiply 4 by to get 1/2. If not, let's do a model. Let's divide our model. So we have, here's the whole marathon, and here is half of the marathon. If we take this half of the marathon and split it into 4 parts, how much of the whole marathon is part? Let's see. 1, 2, 4, 5, 6, 7, 8. Friend will run 1/8 of the marathon. 4 times 1/8 equals 1/2, or we could say 1/2 divided by 4 equals 1/8. If we take half of something and divide it into 4 parts, each part, the value of each part, or the amount of each part, is 1/8. And we could have done that with the linear model as well. And I'll show you that. Here we have our linear model. Now we said we have half of a marathon, and we're going to take half of the marathon and divide it into 4 equal parts. To do that, I will first divide half of the marathon in half, and then I will divide each half into half, and that will give me 1, 2, 3, 4 equal parts. But the question is, how much of the whole marathon is 1 part? It's an 1/8. Why? Because we have 1, 2, 3, 4, 5, 7, 8 equal parts. So each friend will be running 1/8 mile, or 1/8 of an entire or full marathon. Now it's time for you to try it on your own. Pause the video, solve this problem, and come back for the answer. Okay, here's the answer. You should have gotten that D equals 48. We will have 48 1/8 of a gallon. Boys and girls, notice I used multiplication to check my answer. This is how what we're doing is related to everything we learned in Chapter 7 of multiplying fractions. If you need to, rewind the video, write down your questions, create models. We didn't have enough room on this slide to create a linear model, but it would be cool if you challenged yourself by creating a linear model of this problem. Okay? Check to see where you are on the scale. If your practice problem was correct and you understand why, then you are a 3. If you're not so sure, you're a level 2, and make sure you write down your questions. Thanks for watching.